Dear students, welcome to ECA1 class. In today's class, we are going to discuss Y delta and delta Y transformation. Why we use Y delta or delta to Y transformation. If you have a given circuit and that circuit is neither in series nor in parallel, so we use Y delta and delta Y transformation to solve that circuit. So let us consider a circuit in which we are going to combine that R1 circuit through R6. Now you will see that these both resistors are neither in series nor in parallel. So we use Y delta transformation to solve this overall circuit. These are the representation of a Y network. This is basically the Y network. It is also called a T network, in which we have the T-shaped circuit, and here we have a Y type circuit. In delta combination, you will see that the resistors are connected in that way that it forms the shape of delta, or that delta is also known as a pi network, which is similar to the shape of the pi. In today's lecture, we will discuss how we can convert this delta to Y network and this Y network to delta network. So let us consider a delta network, and now we are going to convert that delta network to Y network. Put this Y network in between that delta network, you will get this overall circuit. Here you will see that this is basically the delta network, and you place this Y network into this and you will get this Y network. If you have the values of R, P, R, A, RB and RC, now you have to find the values of R1, R2, R3. When you get the values of R1, R2, R3, it means that you have transformed this delta network to this Y network, and you can remove this RB, RC and RA from circuit and replace it with R1, R2 and R3. Now the target is, when you are converting delta to Y, you have to find the value of Y network, which is R1, R2 and R3. So R1 is basically is equal to RB into RC divided by the total resistance of that sum of the total resistance of that delta network. Now from the figure you will see that R1 is, there is R1 and it is in between these two resistors RC and RB. So in the formula you will see that R1 is equal to RB into RC. If there is R2 in that position, then the formula of R2 is equal to RC multiplied by RB. So if the sequence of the resistors is changed, you will not be confused. You just have to remember that when you are going to find the value of R1, you will see that R1 is bounded between these two resistors. Whatever the value of these two resistors, you have used the relation that R1 is equal to the product of the two resistors in which that R1 is exists and divided by the total resistance, sum of the total resistance of that delta network. So R1 is equal to RB into RC divided by the total sum of total resistance of that delta network. Now the value of R2 is equal to the product of RC and RA divided by the sum of total resistance of delta network. Similarly, the value of R3 is equal to the product of RA and RB divided by the sum of the resistance of that delta network, which is equal to RA plus RB plus RC. Now in the second case, when you are going to transform Y network to delta network, use the same diagram, and you have to find the value of RA, RB, RC. Because you have Y network, it means that you have the values of R1, R2 and R3. When you are converting Y network to delta network, you have to find the values of delta network, and the values of delta network are RA, RB and RC. Now the value of RA basically is equal to the product sum of the product of all the resistors of Y network. In case of RA, you will see that in the relation RA is equal to R1 multiplied by R2, R2 multiplied by R3 plus R1 multiplied by R3 divided by opposite resistor of that delta resistor. And the opposite resistor of this RA is basically R1. So RA is equal to R1 R2 plus R2 R3 plus R1 R3 divided by R1. Now the value of RB is equal to the product of the sum of the product of all the resistors divided by opposite resistance of opposite resistance, which is equal to R2. So RB is equal to R1 R2 plus R2 R3 plus R1 into R3 divided by opposite resistance, which is R2. Similarly, RC is equal to the product of sum of product of all the resistors divided by opposite resistors. The opposite resistor of RC is basically equal to R3. So RC is equal to the product of sum of product of all the resistors of Y network divided by opposite resistor, which is R3. Using these relations, you will convert the Y network to delta network and delta network to the Y network. In order to understand the Y-delta transformation, let us consider an example in which we have a delta network and we have to convert that delta network to Y network. You will see that we have the values of RA, RB, RC. Now we have to find the value of R1, R2 and R3 that is used in the Y network. In the first step, place the Y network in between that delta network. You will get this. Now this is basically the red one are the delta network, and this blue one is basically the Y network. Now you have to find the value of R1, R2 and R3. The value of R1 is basically equal to the product of RA into RB divided by the sum of the total resistance of the delta network. From here you will see that the value of RA is 60 ohm, RB is 30 ohm, RC is 10 ohm. R1 you have to find the value of R1, R2 and R3. Now R1 is equal to basically RA into RB divided by sum of the resistance of the delta network. So you will get the value of R1, which is equal to 18 ohm. Now the value of R2 is basically equal to RB, the product of RB and RC divided by the total sum of the total resistance of that delta network. So R2 is equal to RC RB divided by RA plus RB plus RC. When you substitute the values, you will get the value of R2, which is equal to 3 ohm. Now in the third step, you will have to find the value of R3, which is equal to RA multiplied by RC divided by sum of all the resistance of the delta network. So R3 is equal to RA into RC divided by RA plus RB plus RC. When you substitute the values of these resistance, you will get the value of R3, which is equal to 6 ohm. Now the Y network basically looks like that. R1, which is the value which is equal to 18 ohm, R3 which is equal to 6 ohm, and R2 which is equal to 3 ohm. Now you can replace this delta network with this Y network to solve the circuit. Let us consider another example in which you will see that this resistor is neither in series and parallel with this circuit. So we use Y transformation in this circuit because it looks like, it is basically looks like a pi circuit. So in the first step, you have to replace this pi network to Y network. So when we are going to convert this delta to Y, we have to put a Y network into this delta network. It looks like this. So now we have to find the value of RA, RB and RC. You can name resistor with any name, okay? There is no boundness that you have to assign the value of RA, either R1, R2, R3. You can name it with any name, okay? Now we have to find the value of RA, RB and RC. So now from the figure you will see that RA is basically in between R5 and R2. So RA is equal to R2 into R5 divided the total resistance of that delta R pi network, because it looks like a pi network. So when we substitute the value, we will get the value of RA, which is equal to 18 ohms. Now we have to find the value of RB, which is in between R2 and R4. So RB is equal to R2 into R4 divided by the total resistance of that pi network. You will get the value of RB, which is equal to 3 ohms. Now RC is in between R5 and R4. So RC is equal to R4 into R5 divided by sum of the total resistance of that pi network. Our value of RC is equal to 6 ohm. Now you can replace this circuit with that Y network. It means R2, R5 and R4 will be removed from the circuit. Now the circuit looks like that. This is basically RA, this is RB, and this is RC. Now RB, RC are in series with R6 and R3, and R1 is in series with RA. Now from the figure you will see that it is basically these two are in series, and then here the current is divided into two parts, and RB and R3 are in series. Similarly RC and R6 are in series when you remove R5, R4 and R2 from the circuit. Now the circuit looks like this. Now in the second step you will solve these two resistors which are in series, these two resistors which are in series, and these two resistors that are in series. Now the circuit looks, now find the value of R prime is equal to basically R1 plus RA that are in series. You will get the value which is equal to 38 ohm. Now the value of R, which is basically this, you will solve in the first step RA and R3 in series, and then these two branches are in parallel with each other. So you first solve these two resistors in series and then with parallel with that two resistors. You will get the value of R, which is equal to 24.3 ohms. R prime is basically equal to 38 ohm, R is basically equal to 24.3 ohms, and R7 is already given. So when we add the values of these three resistors, because these three resistors are in series, you will get the value of RAB, which is the equivalent resistance R, which is our required result. We have to find the value of RAB, which is equal to 142.3 ohms. Now let us consider another example in which we have to find the value of I naught, which is the source current. Now from circuit you will see that these resistors are neither in series nor in parallel. It means we have to use Y to delta or delta to Y transformation in this circuit. Now from circuit you analyze that 20, 40 and 60 ohm, basically these three resistors represent a pi shape. Now it means you have to convert this pi shape to the Y network so that you can solve this circuit. So in the first step you will add three resistors, or you will say that you will add a Y network to that pi network, RA, RB and RC. This is basically a Y network. Now we have to find the value of RA, RB and RC. The value of RA is basically equal to the product of R1, R2, because RA is in between R2 and R1. RA is equal to R1 into R2 divided by sum of the resistance of that pi network. We will get the value of RA, which is equal to 10 ohms. Now we have to find the value of RB, which is in between R1 and R3. The value of RB is equal to 6.6 ohm. Now the value of RC is equal to R2 into R3 divided by the whole sum of the whole resistance of that pi network. Now we can replace this pi network with this Y network, and we will replace R1, R3 and R2 with RA, RB and RC. Now the circuit looks like that. This is RA, this is basically a Y network, RB and RC. Now from the figure you will see that this RB and R4 are in series, this RC and R5 are also in series. Now we solve this RB and R4 and RC and R5 with each other. We name it R prime, which is equal to RB plus R4, because these two resistors are in series. So when you substitute the values, we get the value of R prime, which is equal to 16.6 ohms. Now R double prime, which is equal to RC plus R5, because these two resistors are also in series. So R double prime is equal to, when we substitute the values, we will get the value of R double prime, which is equal to 70 ohms. Now from the figure you will see that this is RA, this is R prime, this is R double prime, and this is R6. Now this R prime, R6, R double prime and RA are neither in series nor in parallel. So when we analyze the figure, we will see that this is basically again a pi network. Now we have to replace this pi network with the Y network so that we can solve this circuit. So add another pi circuit into this, another Y network into this pi network. So we name it RD, RE and RF. Now we have to find the value of RD, RE and RF. So RD is basically in between R prime and R double prime. So RD is equal to R prime into R double prime divided by R prime, the sum of the resistors of that pi network. So we get the value of RD, which is equal to 11 ohms. Now RE is in between R prime and R6. So RE is equal to R prime into R6 divided by sum of the resistance of the whole network. So we will get the value of RE, which is equal to 3.11 ohms. Now similarly, RF is in between R6 and R double prime, so the value of RF is equal to 13.1 ohm. Now you can replace these resistors R prime, R double prime and R6 with RD, RE and RF. Now the circuit looks like this. RA, RD, from here it is basically a Y network. This is basically a Y network which we find in the previous slide. So now from the figure you will see that these two resistors are in series, these two resistors are in parallel. Now you have to find the series resistance and this parallel resistor. You will get RG. We say that RG is the resistor which is the resultant of RA and RD. You will see that RG is equal to RA plus RD. When you substitute the values of RA and RD, you will get the value of RG, which is equal to 21 ohms. Now you have to find the value of these two parallel resistors. The parallel resistor RH, we name it RH, which is equal to RE parallel to RF. When you substitute the values, you will get the value of RH, which is equal to 2.51 ohms. Now the circuit looks like that. These two resistors are in series, so we can easily calculate the equivalent resistance of this circuit, which is equal to the series or the sum of Rg plus Rh, which are in series. The value of R equivalent is equal to 23.51. So we have the value of V, we have the value of R equivalent. Now we can easily find the value of I naught, which is the source current. Using Ohm's law, I naught is equal to V by R equivalent. Substituting the values of V and R equivalent, you will get the value of I naught, which is equal to 1.02 ampere. So that's all for today's lecture. I hope with these three detailed examples you will understand the Y to delta and delta to Y transformation. If still you have any confusion or any question, you can comment in comment box. Thank you very much.